guys, today we're going to calculate the velocity of someone walking and running. And we will show you guys how we calculate it. But before we start, we would like to introduce ourselves. I'm Valencia.
I'm Angelica.
I'm Stephen.
I'm Nelson. I'm Ray.
And I, Anthony.
And without any further ado, let's start the video.
Velocity is a vector, a measurement of the rate and direction of motion, or basically how fast something is moving in specific direction. It measures of speed with a direction like 50 minutes per second north.
The velocity time graph shows the velocity of an object that changes over time. It can be used to determine the object's acceleration, displacement, and the nature of its motion.
There are two axes in velocity time graph. The first one is axis. The x-axis represents time. The y-axis represents velocity. Second one is interpretation of the graph. Horizontal line, constant velocity. The graph is a straight horizontal line. The object offers at a constant velocity, zero acceleration. And then over sloping line, positive acceleration. If the graph slopes upward, velocity increase, meaning the object is accelerating. Downward sloping line, negative acceleration. A downward slope indicates negative acceleration.
Okay, so this is the graph that was done by Angelica. So for number one, we calculate the acceleration of Anthony at the first 8.5 seconds. So from this question, the answer is 0.011 meter per second square. So this is not from the formula from y or x, mean for velocity divided with 8.5 seconds.
So now we're going to find out the distance in the first 8.5 seconds. We already know that the base is 8.5 meters and the height is 0.1. So for this case, we're gonna use the triangle formula. So for the final answer is 0.425 meters.
So for the first one, we should calculate the displacement travel from 8.5 to 13 seconds, which is this to this. So the given are this one, this shape, the second shape, and the third shape. So for the second shape, the given are the base and the height. The base are 3 and the height are 0.5. And for the third shape, the height is minus 0.09 and the base is 2.5. Now, let's answer this question. We shall start with the second shape first. If it is a triangle, we shall do the base times height per 2 for divided by 2, which is the base are 3, the base is 3, and the height is 0.5 divided by 2. Which is 3 per 4 or 0.75. And for the last one is the third shape and also a triangle, so we should do b times height per 2, which is b, the base is 2.5 and the height is negative 0.09 per 2, which is negative 9 per 80 or negative 0.1125. But because the displacement and distance couldn't be negative, so we should remove this. We should just ignore this. So the displacement will be 0.75 minus the 0.1125, which is 0.63, or we can round it to 0.6. This is the displacement for number 3 from 8.5 seconds to 13 seconds. And the last one is distance and displacement for the entire time. So I will label this as the first one I will do, and this one the second, and the third. So given for the first shape is 8.5 and 0.1. For the second one is 0.5 and 3, because 11.5 minus by 8.5 is 3. And the last one, the third one, is minus 0.09 and 2. So we should do the distance first. The distance is, because this one is triangle, so we should do the base times height divided by 2. So the base is 8.5 times the height is 0.1 divided by 2. the answer will be 17 per 40 or 0.425. And for the second one is a triangle, 2. So the base is 3. The base is 3 times the height is 0.5 per 2. So the answer will be 3 per 4 or 0.75. And the last one is the third one. It's also a triangle, so we shall do the same formula. The base is 2.5 times the height is 0.09, which is divided by 2, which is minus 9 per 80. We can say this as a negative 0.1125. But because distance couldn't be negative, so we shall remove the negative sign. We shall add this all together. So 0.425 plus 0.75 plus 0.1125 equals to 1.28. This is the distance. Now for the displacement, we should only do this. We should add this too, and the result should be subtracted by this. So 0.425 plus 0.75 equals to 1.17, and this one we shall subtract by this, so it will be 1.17 subtracted by 0.1125 equals to 1.05. We should round it to 1. So the displacement is 1 and the distance is 1.28.
First, a horizontal line. Above the time axis means a constant velocity in the positive direction. Second, a horizontal line on the time axis means the object is at rest. Third, a line crossing the line axis indicates a change in direction. In conclusion, a velocity time graph provides a clear representation of an object motion, including acceleration, deceleration, and displacement over time.